the 27th, 2024, a robotic telescope system in Chile that scans for space objects that pose a threat to Earth sent out a danger alert. It detected an object at a distance of 515,000 miles from Earth, an asteroid whose trajectory indicated a serious risk of collision with our planet. Astronomers named it 2024 YR4, and their subsequent calculations were shocking. They indicated that a probability of this asteroid colliding with Earth was the highest ever recorded. No other known space object has ever had such a high chance of collision with our planet. Further astronomical studies allowed us to estimate the object's size. Its diameter was measured at between 174 and 220 feet, roughly the height of a 15-story building. And while those dimensions might seem modest for a celestial body, in reality, they pose a colossal threat to Earth. Researchers from the University of Western Ontario determined that the force of an impact from an asteroid of this size could be comparable to the explosion of one of the most powerful thermonuclear bombs in existence. That would be more than enough to wipe any megalopolis off the face of the Earth. It's no surprise that the object soon received a second ominous nickname, the City Killer Rock. After 2 more months of observation and refined calculations, astronomers came to an unexpected conclusion. The asteroid no longer posed a direct threat to Earth. The probability of impact turned out to be much lower than initially forecast, but the relief was short-lived. Those same refined calculations showed that the trajectory of 2024 YR4 intersected with the orbit of the Moon, and the likelihood of it striking our satellite was now even higher than its original probability of colliding with Earth. If it happens, it would be the most powerful lunar impact in the last 5,000 years. And it could happen as soon as 2032. Even if the impact were to strike the Moon, the consequences for Earth could be truly catastrophic. Researchers around the world working in the field of planetary defense are already proposing plans to prevent this event. One suggested scenario sounds like something straight out of a science fiction film: launching a nuclear strike against the asteroid to deflect or destroy it. If that plan becomes reality, the mission may fall to NASA. In these images taken by Atlas telescopes, you can see 2024 YR4 moving through space against the backdrop of distant stars. Here, a slightly more detailed images taken by the James Webb Space Telescope, showing a small glowing dot that actually represents a serious threat. This threat emerged directly from the main asteroid belt of our solar system, located between the orbits of Mars and Jupiter. It contains an enormous number of asteroids of various sizes, from hundreds of miles wide to smaller ones like 2024 YR4, which is just under the size of a football field. At one point, the trajectory of this asteroid changed. It now travels along an elongated orbit that passes dangerously close to Earth's orbit. This did not happen by chance. Scientists are convinced that Jupiter is to blame. The gas giant is often called a cosmic shield for our planet. Its enormous gravity indeed attracts asteroids that might otherwise threaten Earth. But few people realize that Jupiter can also have the opposite effect. Recent studies have shown that the gas giant can not only protect but also eject asteroids from the main belt, sending them into the inner solar system. That's exactly what happened with 2024 YR4. Jupiter practically pulled it out of the chaos of the asteroid belt and launched it toward Earth. Following its new orbit, asteroid 2024 YR4 completes a full revolution around the Sun approximately every 4 years. It was first observed in 2024 when it approached Earth at a distance of just 515,000 miles, which is 180 times closer than the distance between Earth and the Sun. The next close approach is expected in 2028, but it's the following pass 4 years later that astronomers believe to pose the most danger. In 2032, the asteroid will again come near Earth and the Moon, and that's when the probability of a catastrophic impact will peak. While trying to determine the probability of this event on February 18, 2025, scientists received a shocking result: 3.1%. At first glance, that number might not sound alarming, but it's important to remember that this is an asteroid capable of destroying an entire megalopolis and triggering a chain of global disasters. In that context, 3.1% is an abnormally high risk. Moreover, it's a record probability of impact in the entire history of astronomical observation. Previously, This record was held by asteroid Apophis, discovered in 2004. At that time, its impact probability was estimated at 2.7%, and even that figure caused a real stir within the scientific community and beyond. In the world of planetary defense, there's a simple rule. If the probability of impact is at least 1%, it already constitutes urgent research and alarm. Now imagine a situation where that figure jumps to 10%, for instance. In that case, you can be sure that the first thing you would hear in the morning on TV and radio or via your smartphone would be an emergency government announcement urging everyone to prepare for the worst. But rest assured, after further studies and calculations, the probability of 2024 YR4 colliding with Earth turned out to be extremely low, just 0.004%, or roughly 1 chance in 25,000. However, that's when the good news ends. Updated NASA data showed that in the same year the asteroid could collide with the Moon, and the probability of that happening is much more serious, 4.3%. What's truly alarming is that in the next 2 years, scientists will not be able to refine these calculations in any way. Right now, 2024 YR4 is too small and too far away for our telescopes to observe. We've simply lost sight of it. It's only when it approaches Earth again in 2028, scientists will be able to recalculate its trajectory and determine whether the risk of a lunar impact has increased. It made an unexpected appearance, made it clear that it poses a serious threat, and left us waiting in suspense for 2 years to see what happens next. If asteroids had a competition for the worst sense of humor, 2024 YR4 would be the undisputed winner. Researchers from the Institute of Astronomy at the University of Hawaii warn us that it would be unwise to expect the risk of 2032 collision with the Moon to decrease over time as it did with the threat to Earth. According to their data, the 4.3% probability is not an overestimate, but a highly realistic assessment. Moreover, scientists believe that the risk may only increase. We're dealing with an object that has never before approached the Moon this closely in all recorded history. Even the slightest interference, such as a weak gravitational pull from another celestial body, including the Sun, could slightly alter its orbit. This gravitational adjustment could turn the 4.3% probability into 100%. Additionally, there's also a risk that the altered trajectory could send the asteroid straight back toward Earth. The distance between our planet and the Moon is only 239,000 miles, which is practically negligible by cosmic standards. Even the tiniest change in the asteroid's motion, for example, during its passage near the Sun, could adjust its course so that 2024 YR4 would no longer pass by, but instead head directly for Earth, where the consequences could be catastrophic. If you think that an asteroid impact with the Moon would be a relatively harmless event and would not have serious consequences for us, you're deeply mistaken. Most scientists working in planetary defense give extremely worrying forecasts. An impact on the lunar surface could trigger a chain of events that would not only create a threat to Earth, but also make future space missions and flights impossible. We'll address this scenario in detail a bit later. For now, let's imagine the darkest possibility. What would happen if the asteroid changed its course and headed straight for Earth? Even for that scenario, scientists have their prognosis. The first and most crucial factor is the asteroid size. The larger it is, the lower our chances of surviving a collision without serious consequences. Small space rocks a few feet across burn up in the atmosphere. Friction turns them into fiery trails that break apart into dust. However, there is a limit to this rule known as the 115-foot law. Any asteroid with a diameter of 115 feet and above is too large to completely burn up in the atmosphere. YR4 is between 174 and 220 feet in diameter, too large to burn up in the atmosphere. But is it large enough to pose a serious threat to us? Let's recall the asteroid that wiped out the dinosaurs. It was about 6.2 miles in diameter, roughly 170 times larger than 2024 YR4. 66 million years ago when it struck Earth, it released an enormous amount of energy, almost incomparable to anything else. But let us try. You may have heard of the Tsar bomber, the most powerful thermonuclear device ever tested, courtesy of the Soviet Union. The energy of that explosion was 3,300 times stronger than the bomb dropped on Hiroshima. Yet, The asteroid that destroyed the dinosaurs released 2 million times more energy than the Tsar bomber. It was one of the most devastating cataclysms in the history of our planet. At the moment of impact, Earth no longer resembled a planet with a mild climate and rich vegetation. It became more like a distant exoplanet where you would never want to find yourself. Although 2024 YR4 is 170 times smaller, its threat remains formidable. Along with his colleagues, Catalina's sky survey engineer and asteroid hunter David Rankin calculated the regions on Earth most likely to be struck when the risk was at its peak. This map shows the so-called risk corridor, which stretches from South America across the Atlantic to countries of sub-Saharan Africa. However, it's important to remember that if the probability of collision rises again, the risk corridor could completely change. The impact could occur anywhere on the planet. The city-killer rock would enter the upper layers of Earth's atmosphere at the same terrifying speed with which it now travels through space, 38,000 miles per hour, or about 10.5 meters per second. Calculations project that if the asteroid enters at a steep angle, it would reach the surface of the planet in less than 10 seconds. The next stage would be the impact itself. Instead of speculating about the scale of destruction, we can turn to a more reliable source, the history of our planet. Similar events have already happened not millions of years ago, but relatively recently. In these images, you're seeing eastern Siberia, Russia. It was here that an asteroid comparable in size to 2024 YR4 landed in 1908. This event remains the largest recorded asteroid strike in human history. Interestingly, there was no direct impact with Earth's surface. The asteroid exploded in the atmosphere, probably at an altitude of 3 to 6 miles. Specialists believe that the object was extremely fragile, composed of rocky material, and could not withstand the heat generated by friction with the air. As a result, an airburst occurred, producing a powerful shock and heat wave. This wave was recorded by seismographs all around the world. The explosion leveled 80 million trees across an area of 830 square miles. Forest fires spread over vast regions. Thunderous booms were heard hundreds of miles away, and windows shattered far beyond the epicenter. For several nights from the Atlantic to central Siberia, the sky glowed with an unusual fiery light. Fortunately, only 3 people died that day as the asteroid exploded over an uninhabited area. If we summarize and try to briefly assess the destructive power of that event, the energy of the explosion was almost 185 times greater than that of the atomic bomb dropped on Hiroshima. There's every reason to believe that asteroid 2024 YR4, with dimensions comparable to the one that exploded over Russia, would cause a similar level of destruction. But this time, the potential impact site may not be an empty woodland, but one of the most densely populated cities in the world, such as New York. If Y4 strikes New York, the consequences would not just be catastrophic, they would go down in history as one of the greatest disasters in the entire existence of civilization. If 2024 YR4 is composed primarily of metallic rock, its structure would be significantly stronger than that of stony asteroids. This means it's highly likely to reach the surface without breaking apart in the atmosphere, and the impact would hit the city directly. Suppose the asteroid struck the central part of Manhattan, for example, the Times Square area. A crater about 1 mile in diameter would form at the epicenter. Complete destruction would occur within a radius of up to 2 miles. This means that from Midtown Manhattan, nothing would remain of the Empire State Building, Grand Central Terminal, and Bryant Park. All buildings in this sector would be leveled, including steel structures, subways, and underground utilities. People at the epicenter would not have time to comprehend the moment of impact. The shock wave would spread across the city for a radius of up to 5 to 6 miles. This would affect the rest of Manhattan, Brooklyn Heights, Williamsburg, and Long Island City. In these areas, the shock wave would shatter windows, destroy building facades, and collapse bridges and overpasses, including parts of the Manhattan, Brooklyn, and Williamsburg bridges. Steel structures of skyscrapers could deform, and many high-rises could partially or completely collapse. Areas within 8 to 10 miles could be engulfed in massive fires. Based on theoretical assumptions, scientists predict that the consequences of a 2024 YR4 impact could be tens of times more destructive than the nuclear bombings of Hiroshima and Nagasaki, though without radiation. It's no surprise that planetary defense specialists worldwide are already discussing projects to prevent such a potential disaster using nuclear weapons. But first, we suggest considering the consequences of a 2024 YR4 impact on the Moon in 2032, which currently has a record 4.3% probability. An impact on the lunar surface would be extremely powerful. Unlike Earth, where the atmosphere can incinerate a small part of an asteroid before it strikes, Y4 would collide with the Moon without any obstacles. Research author and astronomer from the University of Western Ontario, Paul Vert, conducted calculations showing that the collision would release energy equivalent to 6 million tons of TNT. This is akin to a nuclear charge 400 times more powerful than the bomb dropped on Hiroshima. According to him, a crater at least 1 mile in diameter would form at the impact site and a colossal amount of lunar material would be ejected into space. The force of the impact would be so grand that the event could be visible from Earth, but only if the collision occurs on the sunlit side of the Moon. As a result, clouds of dust and rock fragments would rise into space, reflecting sunlight that would be visible to the naked eye and under less favorable conditions through an ordinary amateur telescope. If a collision like this occurs, it would be the most powerful lunar event in the last 5,000 years, according to NASA specialists. Sure, it might look impressive and beautiful in some way. No one in human history has ever had the opportunity to observe such a powerful planetary collision from such close proximity. But behind the grand spectacle are consequences that are initially hard to imagine. Paul Vert, who actively studies Y4, states that almost all of the lunar material ejected into space during the impact will return to the Moon's surface because our satellite's gravity will not allow it to escape permanently. However, he also poses that about 0.2% of the ejected mass would head toward Earth. At first glance, this seems too small to worry about, but estimates show that this amounts to 20 to 200 million pounds of lunar material. For those of us on Earth, there's no cause for panic. Over the course of a few days, all this material would burn up in the atmosphere, creating a meteor shower 1,000 times more intense than usual. According to the scientist, keep in mind that not all humans are on Earth. For the past 20 years, at any given time, at least one person, often several, have been in space, mostly astronauts, aboard the ISS. Although the ISS is planned to be decommissioned 2 years before potential YR4 lunar impact, the Chinese Tiangong space station will still be operational and it also has astronauts aboard. Paul Vert notes that debris from the lunar material would travel slightly slower than typical meteors at about 22,400 miles per hour or 6.2 meters per second. But this is still much faster than most bullets, making the fragments potentially deadly for anything that happens to be in their path. You're seeing the results of an experiment conducted by European Space Agency specialists. A 7 inches aluminium block was struck by a small aluminium sphere weighing only 0.06 ounces, launched at 4.2 meters per second. This is a clear example of what could happen if even a small space object collides with the hull of a spaceship. You might think that fragments of lunar material are not as strong as aluminium spheres, and you'd be correct. But consider the speed of these fragments. Their velocity is higher, so their destructive power could be roughly the same. Such debris could easily pass through an astronaut in open space, leaving no chance of survival. Spacecraft and satellites could be seriously damaged or completely destroyed. For the latter, an even more catastrophic scenario is possible. Currently, there are 11,700 satellites orbiting Earth. If even a portion of them sustains damage from lunar debris, it could lead to their destruction and subsequent collisions with other objects. This effect is known as the Kessler Syndrome, a theoretical scenario in which each collision creates new fragments, increasing the amount of space debris and the likelihood of further accidents. Over time, this chain reaction could result in most satellites being destroyed with their fragments spinning around Earth at high speeds for decades or even centuries before burning up in the atmosphere. This would make any space journeys practically impossible. All of this sounds like the plot of a science fiction movie where the main character is called back into service because they're the only one who knows how to save the planet. However, this outcome is extremely unlikely. The Kessler Syndrome in Earth orbit is possible, but achieving it would require something far more massive than a few million pounds of lunar regolith debris. And yet, scientists do not entirely rule out this seemingly cinematic scenario. Both events, whether a collision with the Moon or with Earth, carry serious threats. Until recently, such events seemed almost inevitable. Today, some scientists have developed a Plan B, which involves a nuclear strike. And this plan could potentially be used against YR4. The concept of the plan is simple, at least at first glance. A nuclear warhead is mounted on a rocket that will be directed straight toward the asteroid. When the spacecraft approaches the target, specialists will calculate the precise moment to detonate it above the surface. This method of detonation can destroy the asteroid much more effectively than a simple kinetic impact, even at incredible speed. According to specialists' estimates, the warhead's power must exceed the bomb dropped on Nagasaki by approximately 50 times. This would be sufficient to break YR4 into many fragments that no longer pose a real threat to Earth, as most would simply burn up in the atmosphere. Preliminary data suggests that the theoretical implementation of this Plan B could occur between late 2029 and the end of 2031, when the trajectory of 2024 Y4 brings it closer to Earth's orbit. Of course, the operation would be extremely complex and risky. Even the slightest miscalculation could cause the mission to fail. If the first launch is unsuccessful, it would take time to implement a second attempt. This is why an early start while the asteroid is still at a significant distance from Earth seems logical. However, this approach has its drawbacks. Accurately hitting a distant target is extremely difficult. The probability of missing is hundreds of times higher than if the launch occurs when the asteroid is closer. For example, when it's near the Moon's orbit. In the second scenario, there's no room for error. A miss would leave no time for a new mission. By 2028, when YR4 approaches again, scientists will be able to accurately determine the probability of its collision with the Moon in 2032. Currently, the probability is 4.3%. Despite this record figure, there's no reason for panic. Even in the most dangerous outcomes, humanity will likely have a way to respond. At least we hope reality does not follow the plot of the film Don't Look Up, where events eerily resemble our situation, and the ending, to put it mildly, leaves much to be desired. That said, as of today, humanity does not have a single space program capable of guaranteed prevention of an asteroid collision with Earth. We've already talked about the asteroid that wiped out the dinosaurs 66 million years ago, causing one of the most mass extinctions in the timeline of all life. But have you considered what would happen if something similar occurred today? Could humanity survive a collision with a giant as powerful as that ancient killer? And what would Earth look like after an impact of such magnitude? 66 million years ago, the dinosaurs were still the rulers of the Earth. These creatures roamed the ancient continents for millions of years. But little did they know that life as they knew it was about to come to an end. From the asteroid belt between Mars and Jupiter came a mountain-sized space rock on a direct collision course with Earth. It hit the planet, leaving behind a huge crater 115 miles in diameter and 12 miles deep. The impact unleashed a cataclysmic force that not only led to the extinction of the dinosaurs, but also nearly wiped out all life on the planet. So what would happen if the same size asteroid traveling at the same speed hit the Earth today in the same place? We can get a fairly good idea by playing out that scenario with what we know of the asteroid and the capabilities that we have with modern technology in stopping such a threat and ensuring the survival of our species. But would humanity survive? Could we stop this cosmic threat? Let's take a closer look at the asteroid that almost ended all life on the planet some 66 million years ago. The Chicxulub asteroid is estimated to have been 6.5 miles in diameter and entered the Earth's atmosphere at a blistering 45,000 miles per hour. When it struck the Earth, it released an enormous amount of energy equal to around 100 teratons of TNT. That's the equivalent of 2 million Tsar bombers all exploding at once. Experts have said that the asteroid hit the planet in the worst place possible, just off the coast of Mexico's Yucatan Peninsula. Had it hit somewhere else, life on Earth would be very different than it is today. You might be asking, wouldn't we be able to detect a huge asteroid on a collision course with Earth? The unnerving truth is that astronomers have recently discovered there are potentially thousands of these asteroids, including some large enough to destroy entire cities and possibly trigger a mass extinction event that are moving on unknowable trajectories around the sun. And one thing we know about asteroids is that they are sneaky and dark celestial objects that reflect very little light and they can pop out of nowhere. For example, consider the solar system's first interstellar visitor, the Oumuamua asteroid. The 400 feet long by 360 wide cigar-pancake-shaped rock was only spotted as it had already passed the sun and only reflected 10% of the sun's light. Yes, it's much smaller than Chicks, but no one had any idea it was out there. Another hair-raising thing is that, on its way back out of the solar system after swinging around the sun on October 14, 2017, it passed the Earth, traveling around 85,700 miles per hour and came within 15 million miles of the Earth, or just 0.16 in astronomical units. Cosmically speaking, it was a close shave. When it comes to planet-killer asteroids hiding behind the sun, there are currently no existing telescopes on Earth that can track or see such objects. And we have absolutely no reliable way to destroy or divert such a large space rock with our current technology. If the worst thing happened, and we did spot some mountain-sized rock moving towards us at high speed, chances are not very good that we'd be able to do anything about it aside from quickly preparing for the impact. So, let's play out this doomsday scenario. Let's imagine that astronomers capture something unusual in the sky coming from the direction of the sun. A black spot against the sun that seems to be growing larger and larger with every passing hour. They estimate the object is a giant asteroid 6½ m in diameter, and it's heading straight for us. Scientists determine the speed of the object is 45,000 miles per hour, and its distance is around 90 million m away, which would give us around 83 days until impact. Governments do their best to try and keep things a secret in order to avoid mass panic and chaos from erupting. But they know it's only a matter of time until someone figures out what's going on or an amateur astronomer finds the asteroid and tells everyone about it. Space programs from all countries get together and try to come up with a plan that could either destroy or redirect the asteroid. The gravity tractor idea is brought up. Unfortunately, there's not enough time to design the spacecraft, plan the trajectory, and calculate the necessary maneuvers. The velocity of an asteroid is primarily determined by the shape of its orbit and its distance from the sun. Asteroids in the asteroid belt typically move at speeds ranging from approximately 38,029 to 55,925 miles per hour. A redirection spacecraft like the one used in the DART mission was used to change the orbit of the moonlit Dowse, which orbits a near-Earth asteroid called Didymos. But this object is much bigger and moving much faster. In other words, imagine trying to redirect a mountain flying faster than a bullet. The idea of launching nuclear weapons at the object is considered. However, no one knows if they will have any effect on the rock, and it could break the object into smaller pieces, which could land in a lot of different places on the planet, causing more destruction. Meanwhile, the big news is finally out, and chaos in the general public ensues. The world is shaken by the unsettling news that an enormous asteroid 6 miles in diameter is hurtling towards Earth and set to collide in just 83 days. The revelation triggers a wave of panic and uncertainty across the globe. In bustling cities and quiet towns alike, people react with a mix of disbelief and fear. Authorities strive to calm the masses, but their reassurances are drowned out by the rising tide of fear. Families race to stockpile food, water, and survival equipment. Most people have by now learned that the only place to hide would be deep underground. High authority figures are moved to underground bunkers like the Cheyenne Mountain Complex, which was designed as a command center in the event of a nuclear war. Many people try to get underground as far as possible. Highways and roads are jammed with vehicles trying to get away from the impact zone. This goes on for months, and it would seem that civilization as we know it has collapsed. By this time, most of the impact zone has been evacuated, and it's now just hours from impact. As the 6 m wide asteroid hurtles toward Earth, it looks like a giant fireball in the sky. As it enters the atmosphere at 12.5 meters per second, the intense friction generates an enormous air blast, heating the surface of the asteroid to extreme temperatures. The air blast from the asteroid's entry causes shock waves that ripple outward. And a deafening sonic boom shatters windows and flattens forests for thousands of miles around. This shock wave travels through the atmosphere, causing significant disturbance on the surface below. The intense passage of the asteroid through the atmosphere produces ionization of air molecules, leading to electromagnetic disturbances affecting electronic equipment over a wide area. And most of the satellites in Earth's orbit are completely destroyed. Communication across the planet goes dead in an instant. All television, radio, and internet signals go silent as those hiding in shelters hold their breath waiting for impact. In seconds, the huge asteroid crashes into Earth's surface with unbelievable force, releasing energy equivalent to millions of 50-megaton nuclear bombs. Huge earthquakes are caused as the Earth's crust is violently displaced and fractured by the asteroid impact. These massive earthquakes are felt around the globe and exceed 11 on the Richter scale. The earthquakes trigger massive tsunamis, and the asteroid causes a huge wave almost 3 miles high that slams into the coastal regions near the impact site and also sends huge 1 m high tsunamis throughout the world's oceans. The impact ejects a massive plume of 25 trillion metric tons of molten material shooting up into the atmosphere. With the temperature of some of this molten material being several times hotter than the surface of the sun, superheated winds moving well over 600 miles per hour radiate outward from the impact point 650 to 00 m outward, shredding vegetation and instantly vaporizing any living creature caught in the path. The molten rock the impact ejected rains down across much of North America and incinerates everything within a 1,000 miles radius, igniting widespread forest fires and scorching the landscape. The atmosphere fills with dust and ash, blocking out sunlight and plunging the Earth into darkness. Dust and sulfurous materials are ejected into the atmosphere and leads to a nuclear winter effect, which leads to a rapid decrease in global temperatures. The dust and sulfur, along with the massive amount of water vapor from the impact, creates acid rain that covers just about everything on the planet. The dust particles block out most of the sunlight, reducing photosynthesis, and most trees and plants that weren't incinerated by the blast die out. Global wildfires increases the amount of atmospheric carbon dioxide levels, which leads to a greenhouse effect that warms up the planet and melts the remaining polar ice, leaving much of the planet in shallow seas. The majority of the Earth's plants and wildlife, which wasn't wiped out in the initial explosion, begins to die off, and a global mass extinction ensues. As for the unlucky humans that didn't find shelter deep underground when the asteroid hit, chances of survival would be close to zero. It goes without saying that this whole scenario might be so terrifying to live through that some people would perish from fear alone. For those who have lived through the impact, surviving the aftermath would be an incredible challenge. Because of the widespread global devastation that has happened from the asteroid impact, survivors would have to stay underground in their shelters for months, depending on how far away they were from ground zero. In the first weeks, there would likely be food and water shortages, depending on what was stored underground. Supply chains would totally be broken, and anything not stored underground would have likely been destroyed. Any livestock not taken underground would have perished within the first few months due to the harsh environmental conditions, including drastic temperature drops. Not to mention a severe disruption in the food chains of all animals. In fact, many species of plants and animals, marine reptiles, fish, whales, and other sea life would likely perish from those food chain disruptions. That is if they survived the impact and after effects alone. Humans would have to stay huddled inside their underground homes for a long time. As far as the outside world is concerned, most of the urban areas close to the impact crater would look like something out of a post-apocalyptic movie. Cities close to the impact site would have faced utter devastation. Buildings, infrastructure, and landscapes within the immediate vicinity of the impact would have been completely obliterated. The shock wave would have leveled structures, uprooted trees, and swept away everything in its path. The intense heat generated by the impact would have ignited widespread fires across the landscape. Combination of debris and flammable materials would have fueled firestorms that raged through urban areas, turning cities into deadly infernos. Entire neighborhoods and cities near the coastlines would have been submerged and destroyed by the relentless force of the tsunamis. The human toll of the impact would be immense. The majority of inhabitants in cities close to ground zero would have perished either from the initial impact, the tsunamis, fires, or subsequent environmental changes. Survivors will face a harsh and inhospitable world, struggling to find food, water, and shelter amidst the devastation. After such a cataclysmic event, humans would have an increased susceptibility to diseases due to weakened immune systems. Setting up community health centers would be key to survival. Being able to generate electricity would also be another important thing at this point. The psychological impact of such an event would be hard to deal with. Many survivors coping with trauma and loss. Surviving all of this would be humanity's greatest challenge. But even after such a terrifying event, there is some hope. Despite all our imperfections, humanity's resilience and potential for overcoming catastrophic events could shine through this major disaster. Indoor farming could be done using hydroponics. We could certainly come up with ideas for a renewable energy source to counter the now dwindling fossil fuel reserves. And after a year or so, it might be possible to start rebuilding infrastructure. If we were able to come together and use our heads and bring out human ingenuity and resourcefulness, we might just survive and the future would certainly be a lot brighter. Having lived through such an experience, it might be decades or even hundreds of years until we recover. But the world would definitely be a much different place than it is today. So now it's time for our amazing viewers to sound off. We want to hear what you think would happen. Could humanity truly survive such an asteroid impact today? And what would your plans be if you discovered a huge asteroid was on its way to Earth? We look forward to reading your comments. Make sure to stay tuned here for more. And thanks for watching.